Good morning, my dear students. In today's class, in the chapter circular motion, we are going to discuss the some application problems on the concept what all we have learned it. So, we had the kinematics of circular motion, dynamics of circular motion, the centrifugal force, relative angular velocity, and we are going to I'm going to introduce the general planar motion. So, based on all this, we'll just focus some set of numericals. Means how in different situations how we can apply the basic concepts what all we have learned it. That particular practice is what I'm going to show it here now. Okay, let me start the class. All these are the numericals based on the applications what all we are going to learn, what all we have learned now, how we can apply in various situations. So just only have to put effort, nothing is there. So we have a block here. Read the question, meanwhile I'll adjust the diagram. Okay, we have this is a block. There's a pulley which is given a velocity. I think these are the things which are, and let this be fixed. Please, all of you, first read the question. Okay, let me read it. In the figure, a block A. Block A is placed on rough, horizontal, fixed surface and connected with a ball B. Means this surface is rough. And connected with the ball. Where is the ball? There is a ball. And we have a string. The block A is in limiting equilibrium. I think this word we are going to underline it. The coefficient of friction between the block A and the rough surface is 0.5. The ball B is at a distance. There's a ball B. Is at a distance L. This is what we have. Below the ball B is now imparted horizontal velocity V naught. The initial acceleration of block A is the initial acceleration. We are just bringing the laws of motion ideas into the discussion on this one. So now start working. Initially it's in limiting equilibrium is telling. So what are the forces that are acting? The block A is in limiting MBG will act here. Here tension. I'll bring B here. There's a tension. There's a tension. Here tension. Here tension. And here a friction will act. Okay, till here I think. Okay, this directly let me write it. Mu mg, the frictional force. So as it is in equilibrium, we'll write equation mu mg minus t equal to 0, t minus mbg equal to 0. Equating these two, mu mb equal to mb. Mu is 0.5, let's see what information we are going to get. This one, okay, there's a one equation, you keep it, and now it is given a velocity v naught. So the tension no longer it will be same, some other tension will come into picture. Earlier tension, let it be T naught. Now the tension acting, let it be T naught. Okay, then the weight mg will act here, the tension T naught, here T naught, and the friction mu mag, and it will accelerate. This L, I'll show it here. Now come for this one. Now look at this block, as it is accelerating T naught minus, okay, the tension no longer T naught, no, some other value, yeah, T, let it be. So now definitely it's telling the initial acceleration of block A. So it will accelerate as the block A moves. Definitely the rope connected to the block A will also move. So what is this point? This point also will have acceleration. Now we are describing now, and what is the path of this? How do it will move? Yes, it will move in a circular path, no doubt. But the tension, what happened, how to calculate is, we are just describing the circular motion at that instant for this particular block B. Then there's a point P which I'll consider. What is the point P? Point P is on a rope. So what is the acceleration of point P? Should be the acceleration of block A. Then I should apply a pseudo force, and how the point P will accelerate down. The point P will accelerate down. Then I'm describing the motion of this block B with respect to that circular motion. Then I should apply a pseudo force, so the pseudo force will come in that direction. Then the equations of motion will be T minus mu mag equal to ma into A. Will it also move? How do the block A will move? How the block B will move? Block B will just move vertically down. So then the equations will be mbg minus T equal to mb into A. Then this, okay, then the circular motion equation will be T plus mbap minus mbg equal to mb v naught square by L. So from where this equation has come, at that instant the block B will moving in a circular path. It's having a tendency to swing also. It will also move. It is also having a tendency to swing also. What about this equation, sir? How come you can write both the equations? This is the due to constraint equation. If the acceleration of block A is A, then acceleration of block B also should be A. The reason for that, they are connected by a common string. That's why the acceleration are equal. Then it's also having a tendency to swing. This is what? Due to swing. Are you getting this one? Now we have to solve this one. So we have almost all the information. First, how to eliminate the tension. Okay, we'll get first acceleration of P equal to this one. So what we have to calculate, the initial acceleration of block A. The A is unknown thing which has to be calculated. Shall we add up these two first? Shall we add up these two? Or directly one thing, you can do one thing, that is up to the value of t here. You know acceleration of A, we all given V naught, then you can solve it. That is not needed, I'll leave it. And this is, okay, no. Let me just t equal to ma into A. What is AP? AP is equal to A, no? Initial acceleration of block is asking, that A only we have to calculate. Substitute all the values. Anybody? Get me that acceleration. No observation. I want really some observation from the students. Really, sir, are you correct with your pseudo force? I'm checking your pseudo force. Is it pseudo force direction correct? No response from anybody. Make observation.
This should not come.
I'm not getting. Pseudo force direction, because we are describing the motion of the block with respect to string. The about point P will rotate, no, due to swing about point P. And what is the point P? Point P is accelerating. So whenever you describe the motion with respect to accelerating frame, you should bring pseudo force. In what direction the point P is accelerating? Downward. Then what direction pseudo force should come? Upward. Okay, are you getting? Not analyzing a. This is the plus. Okay, carry on now. Anybody value? So just shall I say that the ball B will swing about P where the P is accelerating. So therefore I should apply pseudo force. We have done all the problems where it was rotating about a fixed point. Now if it rotates about a point which will accelerate, means bring pseudo force. So what is this? This is the pseudo force. This is, I think, something. Yeah, I'll bring it here. This is pseudo force. Just some example for you. Okay, just I'll do one thing. I'll solve it. Nobody is able to respond. MB acceleration of this is needed, no? So MA plus MB into A is equal to MB V naught square by L plus MBG minus mu MAG. MBG minus mu MAG, that should become equal to 0. So we'll get solving this, we'll get the required answer. 3 meter per second square. So what is the basic idea? If a certain object swings about if a body rotates about a point which is inertial frame, okay, no problem. If it rotates about a point which is accelerating, then bring pseudo force and carry on the problem. Then even the pseudo force will be a part of centripetal force. That's what I meant it. I wanted to bring that idea here. Now you can ask questions, sir. Initially you wrote this equation, again you erased it. mbg minus t equal to mb into a. Tell me, like here, there's the equation 1, there's the equation 2. What about equation 3? What is the motion of the ball B? At the ball B at that instant will try to swing. After some time it will move in a plane. This block, when it comes here, where is the ball be? Ball will be somewhere here, swinging. No, it will be swinging and also moving down. So this is the at that instant we are discussing. At that instant means, so what is the thing? Only it is swinging about point P. So sir, what about this? This will be after some time. So what is the question asked? The initial acceleration of block. Initial is telling. So initial means this will not come into picture. Is it okay? At that instant, the moment ball B is given velocity, at that instant only I asked it. So this will not come into picture.
Sir, A is 2 by 3, sir, and N is 3, sir.
Huh? Yeah.
A is 2 by 3, sir.
A is 2 by 3, huh?
Yes, sir. N is 3.
N is 3. Okay, fine. Yeah, thank you. One problem. Just one problem I wanted you to analyze here. Huh? I'll scroll down. Those who are
mass of block and mass of block B are not mentioned.
Is there? No.
Yes.
Those who are writing, you can write it down afterwards, because I have to cover a lot of concepts. Not possible for you to permit. Just make observation. Huh? Writing you can do later on. Huh? Read this question. This is something, the idea of we have this one. The diagram shows a rod which starts rotating with angular acceleration alpha about vertical axis. Starts rotating means it will accelerate from rest. About vertical axis, passing through one of its end A. This is a vertical axis in horizontal plane. Friction exists between the rod and the bead. This is the bead. This green color is the bead. With the coefficient of friction mu. At the angular velocity of rod increase, the bead starts sliding over the rod, say after time t naught. Now is asking normal force acting on the bead at time t, friction force acting on a bead at time t, and I want the time at which the slipping will occur. One more thing I'm missing. If the bead starts sliding at t equal to t naught, find t naught. Okay, this initial diagram. I think you have to draw the diagrams. It's a question based on diagram. Hardly we have anything equations. Okay, I'll bring the diagram. Now, carefully make observation. At any instant of time, after some time t, it will have angular velocity omega. What are the forces that are acting? The weight of the bead. Here the gravity is present. there'll be a normal contact between the bead and the rod. Then a pseudo force m omega square r, or centrifugal force better you call. This is rougher. Then this is for t less than t naught we are discussing. Then the friction will be here. Let's talk about the let's look at the rod. And this is the bead, no? Sorry, there's a bead. Cross-sectional view, side view. You have to see, otherwise not possible. So the weight of there's a rod, no? The weight of the bead will act downward, and because of that there'll be a normal contact. Then what we notice is like it is rotating. It will have tangential because of angular velocity. It should also have linear velocity. So the linear velocity is what I'm showing here. What makes the, see, who is rotating? The rod is rotating, no? What makes the bead to rotate? What makes the bead to rotate? Who is rotating? Rod is rotating.
Friction.
But what makes the bead to rotate? Think once and answer no. What makes the bead to rotate? Who will push the bead? The rod, no? So there'll be normal contact between whom? Between the bead and the rod. So there'll be normal contact will be acting. And on the rod, so what is that N2? That N2 is the normal contact exerted by the rod on the bead. Because of that, it will have tangent. There's a tangential force. When a tangential force acts on a body, there must be a tangential acceleration. So what is this N2? The rod will push the bead. N2. In turn, the bead will push on the rod. I'm not bothered on the rod. Let's bother. Now look at this one. A tangential force acting. If a tangential force acts, there must be tangential acceleration. Yes, this idea. I don't think so. This is something very big. You can just hold a rod, try to swing the rod, or let somebody try to rotate the rod. You try to hold it. No, you feel that the rod is pushing you. That is what this N2. You can quite experience. I need not to talk much about these things. Okay, now let's get into the mathematics here. We don't have students who draw such diagrams. I'm telling this one. We don't have books. We don't have students. Nobody wants to, like, who is pushing the bead? The rod is pushing, so there should be normal contact. Why do this N1? The weight will try to pull down. Therefore, the normal contact. That N1 we have to show on the rod also. No, this much is what we have. So first, vertical equilibrium of bead. Then we know A tangential equal to R alpha. What is A tangential? Who will provide the tangential acceleration? The normal contact, M into AT. So therefore this N into MR alpha. What is the total normal contact? N1 square plus N2 square. So this is a total normal contact. What is N1? Mg whole square. What is N2? Mr alpha whole square. So therefore this N is equal to G square plus R alpha whole square. Okay, this you keep it here. Now the bead, what is the state of bead? Bead will rotate along with the rod. That's what, no slipping. So what is the conditional, right? Bead rotates along with the rod. When it rotates along with the rod means what is the friction acting? Should be static. Friction is Static friction. What will happen to static friction? It is independent of normal contact. We know. Go back to basic definition. Friction is static means it is independent of normal contact. So therefore, what we can write here is like F. Who will balance that static friction? Centrifugal force. In the ground frame, the friction provides required centripetal force. Static friction provides required centripetal force. If you are standing somewhere here, the centrifugal force is balanced by the static friction. What is omega? What is omega? Omega should be equal to alpha t. Mr alpha, will write it. Mr. Now with the time, what should happen to static friction? This is for with the time, what should happen to static friction? As t increases, static friction also increases. What is the maximum permitted? What is the maximum permitted? Maximum permitted is mu n, because we have mu, no? He has given mu. He has defined mu. Okay, so the friction between the ring and between the bead and the rod will keep on will increase. Then at one instant, when that becomes equal to limiting, it starts slipping. So he's asking normal force acting on the bead at time t. Okay, fine. This is now we'll concentrate on the instant of time at which slipping occurs. What shall I? Before that, friction force acting on the bead at t greater than t naught. What is this? What is the t naught first of all? If the bead starts sliding at t equal to t naught, find t naught. T less than t naught is what we discussed. Okay, I'll put it. Normal contact force between bead and rod. Okay, there's a one part of the problem. Okay, part 1 got over. Normal force acting on bead at time t naught. Friction force acting on bead at time t greater than t naught is asking. Oh, sorry. Less than t naught. Okay, this also got over. The two unknowns. I just made correction. Okay, this is our answer. There's one answer. Okay, and now if the bead starts sliding at t equal to t naught, find t naught. Bead starts sliding. So what friction should act? Limiting friction should act here. How to get the time at which it will slide? I think we should take help of this condition.
You're asking, sir.
Are you looking at this question? Find if the bead starts sliding
Yes,
at t
sir.
equal to, find t naught. The t naught you have to find out, no? Okay, let me proceed like this, the same diagram. We'll go for one more page. The next part of the problem. What is the condition? For t greater than t naught. Definitely, in the condition given, it will slide. The friction acting will be limiting. The time is what needed. The time at which it occurs. Sorry, t equal to t naught. At which the slipping occurs. At that moment, it is about to slip or motion impending, what you can call. Okay, let's again the same set of equations. N equal to m g square r alpha whole square. We have a lot of the equations, no? Fl equal to mu n Okay, on the beat, what is FL? We have brought from m omega you can write alpha t naught whole square into r. Okay, mu m get cancelled, so g square r square alpha square equal to alpha square t naught square r. So t naught is needed, will be mu r alpha, again inside g square r square alpha square. The time at which it starts. So once it starts slipping, then what is the problem arises? What is the condition will arise? Once it starts slipping, then what is the problem is like it will have also velocity in this direction. It will also have acceleration. Then you can't write this equation. Then what is the equation you should write? M omega square r minus FL equal to some radial acceleration. No longer it will be in circular path. Then person on the ground, what he says, the friction is not sufficient to provide required centripetal force. That's why it is leaving circular path. This is what is asked. Only is asked at that time. Now, what is this rod? This rod is like in a circular in shape. That's what we are discussing. This is, nobody has asked what is the shape of this rod. The rod is having a circular cross section. This is very important. Sir, shape matters. No, nobody asked, sir, is it a rod? I shown it, okay. Here I shown it. Deliberately I shown it. Is it shape matters? I'm really asking one of the best question here. Okay, make observation of this. Make observation of this. So is it shape matters? Means I'm just asking, okay, let it be like this. Rectangular cross section rod, let it be rectangular cross section. Then what is your course of the problem? Any changes to the discussion you make it, or will it be same?
Change.
Yeah, think and answer. No, don't tell immediately, please. Is any history like some very immediately will answer? Immediately people are responding. Think once. I'm asking some best question. How come within fraction you say same? No, huh? Come on, write analyze. Without drawing diagram, nothing. Mg, there's a normal contact N1 on the rod. As it is rotating, now there will be a normal contact N2, and on the rod N2. Okay, this will be a tangential. Okay, till here I think same, no, almost, but the friction, like the rod which is there, no, the friction at this surface depends only on this N1. The friction at this surface depends only on N2. Two frictions you have to show it. I'll give a cross-sectional diagram. Don't respond for my queries immediately, please, because I'll be asking something very essential one. Unless you don't analyze, think it's not possible. Make a habit of thinking. Why I'm asking all these questions is so that you should think. There's a main purpose here, no? The coaching, what we are trying to do, make it like a student should analyze and think. This is the friction one will act here. The friction at one of the side. Suppose if this is the N2, so the friction here will be in this direction. And this will be a tangential. The weight of the bead will act vertically down. I'm unable to show it. And here normal contact. The mg's I'm unable to show it. Okay, if the rod is rectangular cross section, then at individual surface, you have to discuss the friction individually. Since the rod is rectangular cross section, circular cross section, okay, we are able to go for the total normal contact. Here F1 is mu n1, F2 is mu n2. Earlier what we wrote, FL equal to mu n. No, separately you have to discuss the problem here now. Fn equal to mu n1, F2 equal to mu m2. Then the pseudo force is balanced by F1 plus F2. The pseudo force here F1 plus F2 equal to m omega square r. Limiting frictions, these are. So cross section, rectangular cross section, circular cross section are very important. Any doubt you can clarify here? All these are learning problems, learning so that students should analyze, think. It's learning, not for testing, I feel, because you need you have to draw diagrams here. But such questions will come even in mains for you in the weekend. I don't know the teacher what he thinks about the exam. Okay, let's take the next one. Yeah. And there's some idea of spring is what we are introducing here. A bead of mass m moves in a gravity-free region along a smooth fixed ring of radius r. The bead is attached to a spring having natural length. Okay, I think everyone is able to read. The other end of spring is connected to A, connected to a fixed point O on the ring, where AB is equal to, sorry, OA, sorry, this is OA equal to 6r by 5. Line OB is diameter of the ring. Find the speed of bead at A if normal on the bead due to ring at on speed of bead at A if normal on bead due to ring is at A is 0. The rate of change of speed at this instant. Draw the diagram, please draw the diagram. Draw the diagram. It will be this is again very fundamental one. We are bringing the frictional force into the spring force into the picture. I'll give some better diagram. Yeah, you can see this one. We have a diameter. Then we have a spring. One end of spring is connected here. I'll just show only this one. And here is what a bead is there. There's a bead. This much is there. So there's a point O. This is A. This is B. It will make some angle theta that we don't know. Leave it here. We'll have one more reference line. This is the spring constant of K. Gravity free space. Spring elongated or compressed? What is the natural length of the spring? The bead is attached to a spring having natural length. Natural length of the spring is r. I'll, I'll send the kids. Okay, just one. Small kids are, let them play. Let's not disturb. Let them play. Huh? Okay, now, so natural length of spring is r. What is the length OA? OA is given 6r by 5. And radius of the ring is r. So can we calculate what is the elongation in the spring? The elongation in the spring has to be calculated. The elongation of the spring should be equal to x should be equal to OA minus r. OA 6r by 5 r by 5. And how the spring force will act along the direction AO. So here spring force will show it. Simple. Then we don't know this theta. So then it's telling the speed of bead A if normal on bead due to ring at A is 0. There is some speed. The bead is having some speed. Then who will provide for it to move in a circular path? The normal reaction is 0. I'll discuss now one more situation. Time being, there is no normal contact between the bead and the ring. This is the ring actually, and that black color one is a bead. Then kx cos theta should be equal to mv square L. How to, we have x, we know we have spring constant k, then we have to calculate the v there. And what is the length? Okay, this is r, no? mv square r, sorry. It will rotate, this bead will move in a circular path about c, no? So therefore what is the radius of curvature? That should be r. Now we don't know cos theta. How to bring cos theta?
Cos.
I think the circle, you know it. What is the length OA? OA is 6r by 5. So if you look at the circle, this will be 6r by 5. So 3r by 5, 3r by 5, this is r. Cos theta is needed. So cos theta equal to 3r by 5 by r. So 3 by 5. K, what is the elongation? R by 5. Cos theta 3 by 5 equal to m r v square. So what is v is equal to 3 k r square by 25 m. This will be the tangential speed of the bead A at this instant. Now is asking one more, the rate of change in speed at this instant. Rate of change of speed. What is rate of change of speed? Tangential acceleration is called as rate of change of speed in circular motion. Tangential acceleration is called as rate of change of speed. So how to get tangential acceleration? Kx sin theta will act on the bead. It will have tangential acceleration in this direction. It's a retardation, no? Actually it is acting opposite to velocity. Or are you sure, sir, like or if you bring velocity like this, it will become acceleration. So in what direction velocity has not mentioned. Since the spring force will act in this direction, okay, I'm assuming it can be either way. If it is the acceleration is kx sin theta is opposite to velocity, it will be retarding tangential force. In the direction of velocity, it will be accelerating tangential force. That's all. Okay, now what is A tangential? MAT should be equal to kx sine theta. Kmx is r by 5 sine theta 4 by 5 4 kr by 25 m. Getting this one? So spring force, see, who can provide centripetal force or all the thing? If the component of spring force is providing centripetal force, other component is providing tangential force. It can be anything, no, normal contact, tension, weight, friction, spring force. All these forces we know. So due to that, we are analyzing the circular motion. The problem is, if there is a, I'll just discuss some cases, very important for you. Some conditions are there which are essential for you to learn. The same how to get the normal reaction is something very important. Normal reaction in these cases, how to take it. Please, all of you, advance already twice they have asked, so there are all possibility of asking such very beautiful questions here. Okay, let me give the velocity v. Let there be a gravity also present. So due to gravity now, this is some general discussion. Okay, a good number of questions can be asked here. That is one of the question. Let's have some discussion on this one. The weight mg will act. Let's get into the discussion now. There is a ring A. Some velocity is imparted to the ring A. So sorry, B day. This ring is fixed. I will impart some velocity. How you normal contact will be there. It all depends upon the spring force. Now the spring is elongated here, so it will try to pull the ring towards the center. So therefore, if you look at the bead, if this is the ring, we have to learn how the forces are acting here. Okay, this is a part of the ring, and this is our bead, no? Some thick line will take it. Now how the ring will be in contact with this. The bead will be in contact with the ring in this way. Keychain, you'll be having the keychain, no? So when you look at that keychain, things will be off like this. So here, how the forces are acting? Spring force. This is the force towards center. This is and the weight mg will act here. How the normal contact by the ring on the bead should be radially outward. Should be radial. You should not show against kx or mg. It should be along the normal, no? This will be the common normal. Am I right? And if it is any given velocity, okay, give it here. Now, what is the equations you are going to write? Theta. Then how the equations will be? Kx cos theta. This angle we don't know. Let me write mg sine phi minus n. The equation. What about any tangential acceleration? Any tangential acceleration, it should be mg sine phi minus kx cos theta equal to mat. Are you able to understand? If a spring is compressed, then the spring force will act here. All possibilities are there. So many possibilities are there. If such that the spring is compressed, then the spring force will act here. Then there's a possibility that it may be either way. I'm just generalizing concept here. Keychain, so not understanding keychain. I think ring will be there, no, for keychain, and just put it to your finger and see that it has become
Sir,
very
kx sine phi, kx sine theta, sir.
kx. Okay, this one.
Conical.
Okay, I wrote it. This one, cos sine theta. Yeah. No, let me take this ring one. Ring will be when do situation like this will come. This is the center C. If the spring force, if the spring is compressed, the spring force will act here. Mg will act as usual. The normal contact now will act in this direction. So how come you are changing direction? So there's a spring. Spring is compressed. Here spring is elongated. Spring is elongated. Here what about spring? Compressed. Compressed means spring force I have to show in this way. Now look at the normal contact. Normal contact will be there. Again put velocity V0 and let it have a tangential acceleration. I think we have to be very careful now how the ring is in contact, how the bead is in contact with the ring. The normal contact will come. I think you take the keychain, ring will be there for a keychain, and put your finger, try to rotate it and see that how that ring on the keychain will come in contact with your finger. That's what I'm discussing. So this is not, I think, very new for you. What are the equations of motion we can write here again? Okay, this is as usual theta phi. Okay, how the equations of motion will be? We will provide now n plus mg cos phi minus kx cos theta equal to mv naught square L. What about the tangential acceleration? Mg sin phi plus kx sin theta equal to met. If I release from rest, what is the problem? If I release from rest, if the ring is just released here, in that case, you should not equate anything because you should not go for mv naught square. If you release from rest, no, okay, just put v naught 0, then solve like this. But there will be tangential acceleration. So when when do this v naught will come? Mv naught square r. If the bead is given some velocity, then you have to write equation like this. If the bead is just released from rest, in the same problem, I just release from rest, no, then put v naught 0, then write this much of equation. But tangential acceleration will be there, the resultant forces. So the bead, how it comes in contact with the ring, I think matters a lot. You should have a good observation. So this is what when spring is compressed, this is spring is elongated. So I think the spring force also matters. So we should take decision based on the conditions here. Let's go for this is again the block upon a block concept. The system shown is rotated in a horizontal circle with angular velocity omega. Find the minimum value of omega to start a relative motion between the blocks. Where r is the radius, it is missing. I'll show it here. Whose help you have to take it? In which frame you will do better this problem? Rotating frame. Very easy for us to work out here. So show the centrifugal forces acting on each block, tension, then get the idea of the friction. Minimum value of omega to start a relative motion between the blocks. Let's take the diagram first. And the surface between the block M2 and the is smooth. Between the blocks M1 and M2 it is rough. Oh, okay, yeah, no problem. Okay, start working again. You have to show all the forces acting. Maximum all of you immediately go for drawing the diagrams. Drawing the diagram, free body diagram. All this minimum one has to put effort here. Just mere listening to my teaching will not help you, because from your side there should be effort. So there are two ways are there. Either you learn or learn through teacher. So learn through teacher means not just mere looking at screen will not come. From your side the minimum effort should also be there. So there's a normal contact N1, weight M1G will increase the size of the block. Okay, this is about this one. So we'll show first pseudo forces. Pseudo force will act on both. This angular velocity omega, and they are at a distance r. Some other color. M omega 1 square r. Okay, this much is there. Tension strings will be taut. Okay, now okay, till here I think everyone is familiar. Applying centrifugal forces, string will be taut, showing the tension. Till here I think there won't be any issue for you. M1 is 2 kg, M2 is 1 kg. M1 this is 2 kg, this is 1 kg. On both the blocks, pseudo force acting, will it be same? No, this force will be greater. No, M1 is greater than M2 because omega square is same, R is same. So M1 omega square is greater than M2 omega square. I think this will going to help us to get the direction of friction because the same tension is acting. So how to get the direction of friction? Anybody wants to answer?
Left side.
On the block M1.
Yes.
Yes.
Okay, yeah,
Yes.
fine, good, yeah. Are you able to see like everything? See, what you have to do is like a, I don't know, like a strange mindset, like a sir friction will act like this. Why means no sir should act. No, start from here. Centrifugal force, both centrifugal force acting. Both blocks wants to move away. String is taut. Tension will act. Then how to determine the direction of friction? M1 omega square is greater than M2 omega square. So therefore, the friction, the block M1 is having a tendency to move towards right. The friction will act in this direction. There's a friction, no? Then the friction here in this direction. Is asking to get the omega when it's about to slip. What shall I do?
Limiting.
Limiting friction. So I think adding these two equations, so m1 omega square r minus fl Mhm. Tension, sorry. I'll substitute the value of
Sir,
T. Wait. I'll set it. Okay, this will be FL. T will be, FL will get cancelled, no?
yes, sir,
Adding
that's right.
M1 omega square R plus M2 omega square R minus 2T equal to 0. M1 value we know. Let's substitute all the values, unnecessary calculations. So 2 omega we don't know. R is 1. This is 1. Omega square R is 1 minus 2T equals 0. So tension will be 3 omega square. That I'll substitute any one equation. So 2 into omega
Sir, 3 by
square.
2 now.
By 2, sir.
3 by 2. Okay, 3 by 2. R minus 3 omega square by 2 minus FL. What is FL? FL should be equal to mu mg. Mu is 0.5. Mu mg. Mu 2 into 10. This will be 10. Anybody value omega? Root 20.
2 root 5.
2 root 5.
Root 20.
2 root 5. So initially when we look, no, something block अपने block circular motion. I think the idea is little bit very easy when you discuss this in the rotating frame. If you do in ground frame, what are the headaches? Both will move in circular motion. Very difficult to analyze the direction of friction. Please, all of you, everyone should analyze here. In the ground frame, can we do this problem? Please don't say yes or no. I think. Try to imagine this in ground frame. The difficulty what you face is like how to get the direction of friction. Imagine, see that you find a lot of difficulty in making a guess of this limiting friction only. Forget about solving. So therefore in the rotating frame it will be much easier, no? So the frame of reference what you pick up is something essential. I want you to put effort. In the physics, read question, draw the diagram, show all the forces acting. I think to maximum extent things are in order now. After that, what is the conditions given, what is the idea involved, then write equation. Then having all this, what is the unknown thing, what is the known thing, how to reach. That's the last part. Saying very easy. Even a new question comes to me also, I'll do struggle. This is natural, but what we want, we don't want to struggle. But it's not like that. Every problem we will struggle. So better let's accept that struggle. So we'll be in a comfortable zone. What we do, we will try to generalize things. Means if I solve this, okay, I can solve any other problem. No, not like that. Every problem, now previous problem, this one, things are different. Okay, this is about the forces that are acting. Pseudo force, sorry, centrifugal force, m omega square. I don't know that this I'll call x. How to get the direction of friction? Up the incline, down the incline. Anybody wants to answer?
Up the incline.
Up the
Yeah, naturally it should be up the incline.
Yes.
Because component of pseudo force and mg cent both are like down the incline, no? So it has to be this one. Okay, these are the various forces that are acting on the block. Okay, till here. Okay, fine. Huh? No. What was the question given? Like, find the angular velocity at which block loses contact. Will resolve forces perpendicular to incline. Sine theta. Friction also I should resolve, or shall I resolve? Not possible, no? Friction is acting along the incline. The friction is acting along the incline. Component of that perpendicular will be 0. So now get into this much. N omega square x sine theta cos theta equal to x by r. X equal to r cos theta. That will substitute there. N plus omega square x is r cos theta sine theta mg cos theta. What was the condition given? Block should lose contact. For block to lose contact, n must be 0. M get cancelled, so G cos theta also get cancelled. So this should be the angular velocity. If the angular velocity becomes greater than this, the block is going to leave the inclined plane. I think very dangerous, no? We'll do have some equipments like this. The block will be there. So at one particular angular velocity, it is going to leave this rotating plane. You can just select it, it will fly off like.
So could you scroll up?
We have a small block slides on a frictionless table. It is constrained to move inside a cylinder of radius 1 meter fixed to table. At t equals 0, block is moving along circumference inside the ring with speed v0. The coefficient of friction between the block and the ring is a ring or cylinder, anything it can be. This is cylinder here. Find the velocity of the block at t equal 1 second. See, you may find very difficult. Just dining table will be having a plate. Keep like this. You take some any block, keep it here. So let that block be in contact with the rim. Shall I call this a rim? The side edges are called as a rim, no, for circular plate. You give some velocity to this. Just strike like this. How in carrom board you strike, no, like that you strike this one. The block should be in contact with the rim. It will go round and after some time it will come to rest. Any reason for that? There will be friction between the bottom of the plate and also the side wall of the plate. The top view is what you are seeing here. That's all. We have to open eyes. We have to open eyes. We have to open eyes. Table like a plate is there, no? So the side wall of the plate is called as a like a rim. This is called like a rim. And the bottom. So plate will have two things, no? Rim as a rim surface, rim and the bottom surface. There is no friction between the bottom and the block. There will be friction between the block and the rim. So you can also call this as a rim. Block and the rim, actually it is. No, it has become ring. Yeah. Again, get the diagrams. Where to show block. Radius will be r. There is a block of mass m. How the normal contact? There will be two normal contact. One normal contact N2. The other normal contact. I have to show the diagram. I'll bring one more. There's a side wall I'm showing thick. Here is a block. The block is present here. There are two normal contact. One normal contact and one other normal contact N2. Friction I can't show it. Okay, the surface is rough. I think more than this I can't help you. That N2 is what I'm showing. N1 will be out of the plane. Mg will be into the plane. Cannot be shown. And it is given velocity V0 here now. How the friction should act? Tangential to the rim on the block. This surface is smooth. The rim is rough. Now, oval power requires centripetal, the normal contact. So, N2 is equal to mv0 square r. Then tangential retardation minus mat equal to friction. Friction is what? Mu N2. N2 is m v square r will write it. Velocity at any instant. At t equals 0, this is a condition given. Hey, mute it. Komal Chowdhury, mute it. Okay, thank you. No, at any instant of time, let it be here. Okay, this is at any instant of time. At time t, it will be here. That is what we are writing equation. So at minus at equal to now mu v square by r. This at you can write it as dv by dt. dv by v square equal to mu r dt. At t equals 0, it was given velocity v0. At any time t, let v be the velocity. The integration of this will be v minus 2 plus 1 minus 1 by v, v0, v limit. Some kinematics of idea of that. 1 by v0 mu t by r equal to 1 by v. V naught R equal to R minus mu V naught T. So look at the velocity will keep on decrease is telling. So who is providing centripetal force? This is very important, please. The normal contact. How, sir, how weight will act? Weight will act, weight of the block will act into the plane of paper. Weight of block will act into the plane of paper. So many problems will come now, you start thinking. So how is the cylinder? Cylinder, like it is, you are seeing the cross-sectional view. So only thing is somehow the diagram, afterwards it's all kinematics. There is a dynamics part. Who will provide centripetal force? The normal contact. Afterwards all kinematics. Most of the numericals, what you get in advanced now will be of this kind. Read the question, draw the diagram. Who is providing required centripetal force? Write that equation. Then go for the kinematics approach. Now the same conditions. So if I make the weight the same similar, like some pipe will take it, some drainage pipe you'll be seeing, no? There you take some block and try to project. I think in your home also you can check some any pipe is available. In that you take some small wooden block or some sort of this one. It's somewhere at the bottom you velocity and see that it will start moving, no? Then again you can start thinking N, mg here, mg will act here, then component of mg will come into picture. I'll slide, I'll go for, we'll slide down. Huh?
Sir, 0 get 1 by V is equals to 0.
Yes, sir.
Yes.
No, I'm not getting.
1 by V, you are getting 0, sir.
Oh, it will come to rest, huh?
Yes.
No, sir, 1 by V is equals to 0.
Yes, sir. V is a non-defined variable.
Somewhere, let me check calculation. I'm okay, this one. Yeah.
Minus sign.
Minus sign.
Minus. Yes.
Yes.
Now check it. What do we'll get it?
I think yes, sir.
Plus should come.
No. Check the answer. Will not be 0.
1 by 20. 1 by 5.
5, sir.
Yeah.
Yes.
Just 5, huh? Yeah.
Yeah.
The negative sign there. Should keep on decrease here, that's all. Okay, I think, see, this what? You need all this background. Tell me, like, this is not physics, I'm making clear. This is what, very general. This is what the physics writing equation, but these are very general observation everyone must have. We'll go into like a planar motion. If a body moves in a plane, then how to discuss this circular motion ideas. The velocity of particle moving in a curvilinear path varies with the time as v equal to bt I cap plus c t square j cap meter per second. Find a tangential, a normal, total acceleration and radius of curvature at time t. What is r? R means radius of curvature. Okay, it is moving in some plane. Okay, let's start here. How the path? Okay, some path. Rough this one to make students to think I'm bringing. Sir, are you sure path will be like this? I too don't know. Some curve I should draw. No, there. No, there is a particle. So there's a path. Then it's telling like it's velocity. So how are you sure why path? You look at the I cap, J cap. Am I right? It should move in first quadrant only. Plus I cap plus J cap is there. So somewhere the path I'm telling. Now, what are the things? Tangential acceleration. We know now many little bit better picture about the circular motion. There should be the somewhere center of curvature about this point. So towards center of the curvature, there should be a normal. Total acceleration vector like this. So this is the radius of curvature r. What is r? R is called as radius of curvature. We should find out all these things with only this much of information. So we have what is a tangential? Rate of change of speed, no? What we have is velocity. I think the basic definitions we have to go for it. So tangential acceleration. What is the definition for tangential acceleration? Tangential acceleration is equal to rate of change of speed. We have velocity. Can we calculate the speed? Bt square c square b square t square c square t to power of 4. Okay, the speed is being asked. Okay, we'll calculate the speed. Then rate of change of speed. So I'm going to define a tangential like this is equal to dv by dt. So dv by dt, let me differentiate this equation with respect to time. First 1 by 2 root then this will become 2b square t plus 4c square t cube. Two get cancelled, so b square t there's a tangential acceleration, I got it. Then what about normal acceleration? How do we find out normal acceleration? Normal acceleration is just v square r.
Sir, 2c square t.
2c square. Oh yeah, 2 will be there. 2c square t cube. Okay, done. Yeah. Okay, after getting this, so I got now so this is a tangential is what I got it. Total acceleration, how you define acceleration? Rate of change of velocity. Go back to kinematics. So therefore a bar equal to dv bar by dt. Shall we differentiate dv bar by dt? This equation you have to differentiate. So this will become bi cap plus 2ct j cap. In circular motion, what is total acceleration? A square equal to an square plus at square. What is a square? The magnitude of this. This will become b square plus 2ct whole square. A tangential square. I should square this one. Then from here we'll get the normal acceleration. The whole route this is. Okay, no. Only just I wanted to bring that the definitions of what do you mean by tangential acceleration is the rate of change of speed. Total acceleration, the what we say dv bar by dt is related to this. I think in the first circular motion kinematics I introduced this, you might have not noticed. Rate of change of speed is tangential acceleration, rate of change of velocity is total acceleration. What is A normal? A normal is v square by r. We don't know r, that's why you can ask question, sir, you already have no v. So why you are not writing an as v square by r? Because I don't know an. I don't know r. Radius of curvature I don't know. Sir, what is radius of curvature? Why there is no circle? I think the object moves in curvilinear path. The special case of curvilinear path is the circular motion. Go back in the beginning we started, no? That's what we are putting here. No, for different points, so somewhere it will move like this, no, again. Where the center of curvature will be different for different instants of time. The distance from the point on a path to the center of curvature is called as the radius of curvature. In calculus we do have a formula, but for us we use this approach. I don't know radius of curvature, that's why I am not writing A normal square equal to V square by R. Now I know A normal, I know V square. Can I bring radius of curvature? Yes. What is the radius of curvature will be? V square by A. Can you recollect this? We have discussed where? In the projectile motion. Do we know n? We have. Do we know v square? Substitute. You'll get the radius of curvature. This complete. Don't get scared with the lengthy. Maybe some small ideas are there. That's all here. So if a body moves in some curved path, so there's a method what we can apply here. Let me this planar motion will trouble you a lot. I'll give some example. You can see that most of students will just laugh when I give this example. The object is moving along x-axis with a constant speed v. This distance, let me give b. I want angular velocity of this object above the origin. So I'll write the question. The particle is moving with a velocity v equal to vi cap as shown. Find angular velocity of particle about origin, or about an z-axis passing through origin, or about z-axis, or about origin here. So where is the circular motion and you are telling angular velocity? This is the height of physics, sir. Like nothing wrong, student, commenting on your teacher. First of all, where is circular motion? Am I right? Just moving horizontally, why you are bringing something, why you are asking angular velocity. Okay, we'll do one thing. Angular velocity doesn't mean that it should rotate. Because what is the basic definition of angular velocity? Rate of change of angular displacement. So what is angular displacement? The angle made by the particle with some reference point. So here we do have, look at this direction. Initially the particle is, after some time where the particle, after some time the particle will be here. After some time the particle will be here. Like this you keep on extending. So after the velocity of particle will be same v only. So now it was making an angle earlier theta. Now look at this angle theta 1. Now the angle theta 2. Now this radius vector is r1, this r2, this r. So at this point it was having angular velocity omega. Omega naught will write. Now it is having angular velocity omega 1. The radius vector, is it rotating? So not understanding what you are saying. Okay, we'll do one thing. We'll take some example. Don't okay. Don't bother about particle. Look at the arrow. Arrow is rotating. Arrow is rotating, no? Particle will move horizontally only. But arrow is rotating. Arrow is having angular displacement. That's what. But you should ask. You should say like angular velocity of that arrow. Why you are saying angular velocity of particle? What is this r bar now? R bar is the position vector of particle. So this position vector now will have angular displacement because of the particle is having angular velocity. The method, this way we have to analyze here. Okay, let's get into the calculation. How to find out this? Okay, now circular motion means not only object revolving in a circle. I think from that idea, slowly we have to come out. Where all you want, you can bring circular motion. So kinematics also there is circular motion is there, S. So slowly now a general idea of circular motion one has to develop. There's a necessity. Now this was the velocity v. I'll resolve this velocity into two components. One v perpendicular, other v parallel. This is r, let this be theta. If this is theta, this will be theta. Then how you define angular velocity? V perpendicular equal to r omega naught. And this information is what given for us. Sin theta equal to b by r. R equal to b sin theta. So why you are writing v equal to r omega, v perpendicular r omega? In the circular motion, how tangential velocity, this is the tangential velocity, no? So but this is the path. I know this is a path, but we are describing the circular motion. Then resolve component of velocity of the particle perpendicular to the radius vector, position radius vector here, or position vector. This will become now tangential. Component of velocity perpendicular to position vector, radius vector. That should be taken here, no? That should be substituted here. This is the position vector, this is the angular velocity. Now what is r? B sin theta. This is omega. What is v perpendicular? V perpendicular should be v sin theta. So omega naught is equal to v sin square theta by b. This will be the angular velocity of the particle about origin. Okay, now it's that circle only. If I say, then I'll call circular motion. I think let's come out of that. I can define angular velocity here. I can find out angular velocity. Let's take some more example like projectile motion. We'll take it. I'll project a body at an angle theta with horizontal. Here only, let me maximum. Okay, just an idea that one. It's not that compulsory. Circular motion concept is very important. We have projected an object with a speed u at an angle theta. When it is at highest point, I'm asking you what is the angular velocity of the projectile with respect to point of projection. Find angular velocity of particle about point of projection when it is at highest point. Now, what is r bar? R bar we have to define like this. Okay, I'll bring the r bar, no problem. Are projected with a velocity u at an angle theta. U cos theta, the velocity, that one. What shall I do now? So we'll have a rough diagram. This is u cos theta. This is r. We know this is the range. This is r, no? Capital R, r by 2. Then we'll resolve this velocity component v perpendicular, v parallel. What is that v parallel? V parallel will become radial velocity. Please do understand what is radial velocity as v parallel. We can write it. So what is the thing v perpendicular? This will be this angle also, we don't know. Not theta. It should not be theta, no? Are you looking at this? This is not theta. Some phi. So what is v perpendicular? V perpendicular will be u cos theta sin phi. Then the angular velocity is given by omega naught equal to v perpendicular by r. V perpendicular, okay, somehow we got it. What about r? Sin phi also we don't know. So let's write sin phi. Sin phi will be h by r. So sin phi, I'll write h by r. U cos theta what is r? Small r is a right angle triangle. We have next page, we'll take it here. So this will be omega naught u cos theta h r square will be r square by 4 plus h square. What are h? U square sin square theta by 2g. What about the range? Range is given by u square sin theta cos theta by g. 2u. Substitute them, you'll get the angular velocity. But sir, there's no circular motion. Okay, let's not bother. Sir, can you say also about the accelerations? Yeah, we can go for, because g is acting. Component of g is acting here now. G is acting. Now component of g you resolve. That will be centripetal acceleration. About O. Don't go for acceleration, just only angular velocity you can learn it, because curvilinear is not a part of syllabus. We should have just some general idea. If it actually with respect to ground, it is describing parabolic path. Okay, agreed. With respect to point of origin, we can also say that it is moving in a curvilinear path. That's what they're suggesting us to think here. Now, can we describe the motion with respect to any other point? Yes, we can describe now. Now, suppose a body is moving in circular path. There's a last one more very generalized discussion. I'll make it. No, this object is moving in circular path. I'll bring circular path only. The object is moving in a circular path. There's no doubt. Now, the reference point, I can change it. Let me start with O point P1, P2. This is the center of circle. The object is here. It is moving with a constant speed in a circular path of radius r. This also at a distance r and r. So when the same object comes here, I'll ask you what will be the angular velocity of the particle about C, about P1, about P2. I can define about any point. Actually, what happened? The particle is moving. Particle is moving in circular path. With constant speed v. There's a condition. Now I'll ask you find angular velocity of particle about point C, comma P1, P2 when it is at B. About C, what should be the angular velocity? Here only angular velocity about C. Omega C should be equal to V by R. Omega P1. So what is the how is this velocity? Perpendicular to position vector. So therefore this will be V by R plus R. Then about this point, to R plus R, or if you want to write some X, it will become very important for you. So if a particle moves in a circular path with a constant speed v about its center, then what will be the angular velocity about any point on the circumference? Will be v by 2r. If v by r is omega c, about any point will become half of that one. Means what is the meaning of this? Not only like this, we can conclude here now. About c, angular velocity is omega. Somewhere some arbitrary point I'll bring it. About p, how much it will be? So for that, what you can do is, this is a velocity. This is a radius r. Then omega c, how much you write? V by r. What about p? About p means what we should do? Again, we have to bring a mathematics like this. This is a radius r. Okay, fine. Okay, this will be. So what is the point p now? Point p is some arbitrary point on any circumference anywhere. About p, how much it will be? What we should do? So we should go for this calculation r. We should resolve. You should resolve component of velocity perpendicular to it. Solve it. You'll again end up with v by 2r only. If omega c is the angular velocity of the particle about its center, then about any point on the circumference will be half of it. I'll ask you now to calculate about this. I think you know mathematics. Carry on with the mathematics here. okay, this will be theta, you take it. If this is theta, this should be theta, this should be theta. There's a totally different problem. I just brought a generalized thing. What is angular velocity? About center is omega c equal to v by r. No, so we'll go for omega p. Omega p, what omega p should be equal to? Omega p should be equal to v cos theta by r. Anybody how to bring r, the triangle? Now what can be this r cos theta? R cos theta. So what is r? You can write v cos theta by 2r cos theta. So v by 2r. What is v by r? What is the conclusion you can make it? If omega c is the angular velocity of particle about its center, then about any point on the circumference, what is the angular velocity? Will be half of it. It was very simple. I thought here mathematically I am bringing it. What is point P? Point P on the circumference. What is omega c? Angular velocity about its center. Then what is angular velocity about any point on the circumference? Will be half of it. So there is one golden statement. Angular velocity of a particle about any point. About any point is telling where the point, let it be wherever it may be. About any point on the circumference is equal to half of the angular velocity of particle about its center of circle. This is last conclusion is a general one, very generalized one. Sir, can you calculate the centripetal acceleration? As few quantities we can calculate, few quantities not possible. We have to total acceleration not possible. Centripetal acceleration, how you define? An equal to v square by r. V cos theta we know. We know this radius of curvature. We'll get the centripetal acceleration. It will have tangential acceleration. It will have radial acceleration. Total acceleration very difficult to calculate. Again, you should differentiate dr by dt. It's a big headache all. Just have some general idea. So it's not like something object moves in circular path. Okay, we are going to discuss circular motion. No, let it move in a straight line. Let it move in some curved path, parabolic. What will be that? Can you define like a ideas of circular motion? Yes. About any point, what is the angular velocity? We can apply. What is the basic method? Tangential velocity should be equal to radius vector into angular velocity. How the tangential velocity and radius vector should be perpendicular to each other. Curvilinear is not a part of syllabus, but we should have some general idea. That's all here. Okay, kids, like we had the discussion about the some different numericals. I brought it. All these are just based on like F tangential equal to mass into tangential acceleration. Mass into tangential acceleration. Centripetal force is equal to m omega square r. Then kinematics of circular motion we have brought it. So all some what all we study, no, that we are applying in a part wise here. This is what happens for you in the exams. So in the exams, the numerical what you get, you don't know to what topic it belongs. Something circular motion. You have to read question, you have to make a guess of like to what topic in circular motion it belongs. Then bring that idea. Curvilinear motion is a very generalized conclusion of circular motion. Again, in depth we can't go for it because in the first derivation I made it. Radial acceleration I brought it. Tangential acceleration. normal acceleration, all they will come. So curvilinear is not a part of syllabus. A very general information is needed. That's why I discussed in the end. You focus more on the centrifugal other application problems. Okay, thank you all of you.